8.4.3 Solve rational inequalities. As such a question, how could I find and test critical points when solving rational inequalities? Skill, I can solve rational inequalities. Solve for all excluded values and solutions to the inequality. Then, graph the solution on the number line and write the solution in interval notation. 4x over x minus 5 squared is greater than or equal to 0. Let's write our excluded value. X cannot equal 5 because that would make it undefined here. Well, let's solve this. We'll cross multiply. We get 4x is greater than or equal to 0. Alright, divide by 4. X is greater than or equal to 0. So 0 and 5 are what you would call critical points. They're numbers that could be excluded, they're solutions, intercepts. It's stuff you're going to test out to see where you would shade the answer. So I'll make a little number line. We have 0 here, 5 here. We want to test a number that's less than 0, like -1 for example. We want to test a number between 0 and 5, let's do 1, and then a number greater than 5, let's do 6. You choose any number between there. I just chose those because they look easier. Okay, so let's plug in -1 into the original equation. So that's going to be -4 over -6 squared, that's 36. That's a negative number. That is not greater than 0. Okay, let's do the next one. What if we plug it in 1 for x? 4 times 1 over 1 minus 5 squared. So that'd be 4 over 16. That's a positive number. We want that, so that one's good. Okay, and then let's plug in 6. 4 times 6 over 6 minus 5 squared. So that's going to be 24 over 1 squared. That's just 1. That's a positive number as well. So that works. So it works anywhere that's greater than 0 except 5. Because 5 is an excluded value. Now if we test if it was at 0, 0 times 4 over 0 minus 5, that's 0 over 25, that's still 0. It has a line under it, so that also works. So when you have critical points, test the critical points. A lot of times they'll be undefined. That's when you would put a hole there. If they give you a number that works, it'll be included in the solution, and then choose some number in between each of those critical points to see if it's in the solution. So in this case, we could graph our answer. We have 0 here. We have 5. And then everything else is shaded in between 0 and 5, and then after 5. Your interval solution would be from 0 to 5, or it's a region 5 to infinity. If you want to write it as an inequality, you'd have 0 is less than or equal to x is less than 5, or x is greater than 5. Try the other examples on your own.